Right, okay, so good afternoon everybody and welcome to today's webinar. We're very pleased to welcome Rob Shaw of Rob Shaw Associates Ltd today, who's very kindly agreed to deliver this session. We also have Alison Hind joining us from Switzerland, who spearheads the IOSH Swiss Network webinars. I'll shortly hand you over to Alison, who's going to give a brief introduction. But before I hand you over, I just want to mention just a few things. So firstly, for those of you who haven't attended one of our IOSH webinars, I'm Ben Pollard. I'll be taking care of the technical aspects today. So any problems, and I will try to assist as best as I can. So on your screen then, most likely located at the top left-hand side, you should notice a couple of options, which are chat and Q&A. If you have any technical issues, audio problems, or anything like that, and you need to message me at any point, please use the chat option and ask tell us your problems there, and I'll be able to respond to you. If you have any questions specifically to Rob with regards to the content of his presentation, you can ask those in the Q&A option. At the end of Rob's presentation, we'll do a Q&A, both verbally and written, but I will talk to you more about this nearer the time. So finally, just so that you are aware, the session is being recorded for future playback. And with all that said, I'm now going to hand you over to Alison to kickstart the session. So Alison, over to you.
Thank you very much, Ben. Good afternoon and welcome everyone to this webinar on slips, trips and falls. So this webinar has been really popular. It's got our most participants so far. 60% of all hospital visits related to slips, trips and falls, so it's easy to see why it's been such a popular subject. Because we've got so many new people, I wanted to take a few minutes to talk about who we are at the IOSH Swiss Network. So IOSH Swiss Network, even the name is slightly misleading. IOSH are providing us with a structure and credibility, a framework for doing the work that we're doing. But many of our members, the people who come to our face-to-face meetings and our webinars, are not IOSH members. We are open to everyone who has an interest in occupational safety, health, environmental management. The second part of our title, Swiss. So our foundations are in Switzerland, and our face-to-face meetings have been in Switzerland, but actually representation for IOSH across Europe is very weak. And so particularly for these webinars, we are inviting people from all over Europe to join, and we welcome them. So please, if you're not an IOSH member and you're not Swiss, please still join us and be part of what we're doing. So the goals for IOSH Swiss Network, first of all, we're interested in professional development. For our webinars and for the face-to-face meetings, we're giving out certificates which you can use as evidence whether you're following the IOSH route or a different trade association. Everyone's interested in measuring and maintaining their technical competence. Secondly, we're interested in networking. We have a WhatsApp group which is quite current. A lot of things go up there. I noticed just recently there's a job advert gone up there, which is good to see. So that's a continuous sort of news feed. We also have a LinkedIn site, which is a much more sort of the external face of what we're doing. So maybe a more static asking questions. Both of those are open to everyone to join. All you have to do is go into the app and then search on IOSH Swiss Network and it should come up. If you have any problems getting into it, then please email me. I've put my name down the bottom there. And if you have any questions about what we're doing and whether you'd like to join us, then please email me as well. Okay, thank you. So it's my great pleasure today to welcome Rob Shaw to speak to us. Rob has worked for the Health and Safety Laboratory, which is the technical arm of Health and Safety Executive, the UK regulator, for 14 years or a very long time. He is a technical expert in this subject. So slips, trips and falls, you know, we often get caught up in the sort of housekeeping, moving the wires, moving the boxes. That's really important. But Rob's going to come at it from a much more technical perspective. So looking at fall prevention, specification of floors, falls from stairs, cleaning practices, footwear, human factors, all these sort of things are going to come into his presentation, and hopefully we can learn from those and try and reduce some of those 60% of hospital visits that I talked about earlier. Okay, so passing over to Rob. Thank you very much for joining us.
Thank you very much, Alison. Good afternoon, everyone, and thank you very much indeed for the invite to come and speak to you. As Alison has said, I'm Rob Shaw, former technical specialist of the Health and Safety Executive, so the UK regulator, and I'll start with just a little bit of background about who Rob Shaw Associates are. It's myself and my business partner Rachel, both of whom previously worked for HSE. Rachel is a project manager and commercial development officer, and she does all of the side that I can't do as an enormous nerd, and I do all the enormous nerd side. And so the enormous nerd side for me was slips, trips and falls. That's all I did for HSE for a decade and a half. It's where I got my winning haircut and the twitch in this eye. My job involved a number of things, one of which was incident investigation. So a lot of investigating accidents, working out what happened and why, what could be done to prevent similar incidents in the future. So the focus of the presentation today is going to be on some of those root causes. Hopefully we'll have a little bit of time to cover some of the potential solutions. One of the problems that I see with slips, trips and falls more often than anything else is they're not seen as particularly serious. And Alison's already alluded to the fact that actually slips, trips and falls lead to one of the highest levels of serious injury worldwide in most industries, actually, particularly in terms of hospitalizations, broken bones. And unfortunately, in my line of work, a fair number of fatal accidents, the root cause is a slip, trip or fall. But we also see them as things that we can't do very much about. People should be paying more attention, or it's about the trailing cables and so on that Alison's mentioned. My experience is that the solutions to slips, trips and falls are almost universally quite simple, and quite often they're quite inexpensive to do, which is great news. But the problem is, because we don't understand the correct root cause of why we've had our slip, our trip or our fall, we don't put the right simple solution in place, and we don't actually stop the problem. So what I'm going to cover very briefly today, I would normally do a session like this over a full day. I sometimes do a full day on slips and trips and a full day on stairs. So you'll be very pleased that we're cramming this into an hour. But I'm going to cover slips and trips, and I'm going to cover them separately because they're very different things. And I'm also going to talk very briefly about some of the things that give rise to a risk of falling on stairs. Falling on stairs is one of the things in my line of work that tends to seriously injure and kill the most people. And it's also something that you can manage the risk with some very simple changes. So hopefully the session will be for you very interesting, and it's quite visual. I'm going to try not to have many slides like this with a lot of words on. We're going to try and focus on some videos, some images, and to consider all of those things that give rise to a risk of slips and trips. I think the first thing to do with any of these presentations is actually to point out what we're talking about. And for me, one of the things that we forget when it comes to a slip, a trip, or a fall is that actually there's a lot of energy involved. Although we've all had a slip or a trip where we've hit the ground, we've been unfortunate or fortunate enough not to injure ourselves very seriously, and it's very embarrassing, and in some cases it's a little bit funny. Actually, the potential in any slip or trip is that the injury could be very serious. So I'm going to show a video here of a fall in a workplace in the UK. It's the guy here on the back of the truck. This vehicle is designed for carrying reels of steel. So in this industry, we're carrying very, very heavy product. So there's an awful lot of management of risk around that product, because if any of those rolls escape the vehicle or any of those rolls land on a passing member of staff or member of the public, it's usually a fatal incident. So a lot of work has gone into that. But as you see this man step backwards here, he falls from the vehicle. And we're going to see this briefly again in slow motion. The platform moves from under him, which causes him to lose his balance. The initial fall is quite heavy and he does himself some damage. But once he goes off the back of the truck, it's not particularly high. He loses his hard hat because it's not strapped on, and he has a very, very nasty impact. And there were some very, very serious injuries. I believe he was off work for about 8 months. Now, as safety professionals looking at that, the first thing I tend to get from people is, well, he shouldn't have been on the vehicle in the first place. And absolutely, that risk wasn't well managed. But everybody else in that environment walked past that day by day. That was the standard practice until that went wrong. And since then, the business have done some work on reducing the risk of that incident ever happening again. One of the problems with slips and trips is we tend to focus on what we can do after a serious incident. We're not as good at being proactive and actually putting some of these simple protective measures in place before that one nasty fall happens. So hopefully what we'll talk about in the next sort of 40 minutes will be some of the things that give rise to a risk of slipping and tripping and what we can do about some of those things to reduce that risk. I'm going to start by talking about slips. And I'm going to spend most of the presentation talking about slips because slips are more common than trips, usually because they're that bit more difficult to prevent. Trips, we're well aware of the risk factors. You tend to catch your foot on something and fall over. There are some issues around trips, and I will touch on them later on, but there's some more technical problems around slips and what gives people issues and why people lose friction. Those are things that are worth understanding and exploring in a bit more detail. So when we come to look at slips, as a hierarchy of controls, broadly speaking, at the top of that hierarchy is the flooring. And by flooring, I mean any surface that you could be walking on. So it could be an office carpet, it could be the back of a vehicle, it could be some steps to access plant outdoors in a manufacturing environment. But any surface that the person's walking on, if that surface is fit for purpose and it offers a suitable level of slip resistance, in the normal conditions, so if it's outdoors and it's got water on it, if it's in a food manufacturing environment and it's got oils and grease on it, then you won't tend to see slips. And there are many floors out there that offer fantastic levels of grip with all sorts of different contamination on them. If the floor doesn't offer enough grip, then we get into problems that once the floor gets contaminated, it can become slippery. So I'm going to show you in a little bit some of the test methods. I'm not going to expect anyone to remember what I'm talking about in terms of the technical aspects, don't panic, but it's worth having a look at how some of them work, because actually most floors, if not all floors, will give excellent levels of grip in the clean, dry condition. Once you've got some contamination on there, and that could be water, it could be dust, it could be oil, it depends very much on the location and your processes, that's when you tend to have a problem with people losing grip and with people having slips. So lower down on the hierarchy is contamination. If you can prevent that contamination getting on the floor, if your manufacturing process is guarded so that product doesn't escape the production line, if you've got a suitable entrance design so water isn't coming in at the entrance of your building, then by eliminating the contamination on the floor, you're also able to control the risk because the clean, dry floor shouldn't be slippery. Realistically, it can be very difficult to control the contaminant though. Cleaning is a very important part of the process further down on the hierarchy because we clean to take that contamination off the floor. And right at the bottom of the hierarchy of controls is footwear. And it's at the bottom of the hierarchy because it's personal protective equipment. It only protects the individual wearing it, only if they are wearing it, and so on. However, slip-resistant footwear can be a fantastic control in many environments, especially if you already have other requirements for your footwear, toe protection, ankle support, midsole protection. If you can find a boot that does all of those things for you, but also has great slip resistance, then you're onto a winner. So I will talk about briefly flooring, some of the issues and some of the technical problems with choosing good slip resistant flooring, cleaning and some of the challenges with a good cleaning process, and also how well planned cleaning can make a huge difference to risk without spending any more money or time. And we'll talk a little bit about footwear and selecting footwear. Human factors obviously play a role in all of these topics. They're particularly critical around cleaning, and I'll give one example when we talk about cleaning. The person doing the cleaning task has a huge influence, far more than the equipment or the chemical, on whether that process works. So training, supervision, management, understanding are all very, very important in terms of managing slip risk. So we'll start with flooring. And we're going to start by getting very, very technical. Don't panic, don't log out, don't leave. I'm not expecting anyone to memorize this. I'm not expecting anybody to know what the numbers mean. I put this up because it's quite important to understand that when we go out to a site to undertake an assessment of how slippery the floor is, we can measure the floor either as it comes off the production line when we're choosing a new floor for an environment, or when we're investigating an accident or looking at how good a floor is in its installed condition. We need to take a measurement of the coefficient of friction, how much grip there is on the floor. That's the middle column. If we can measure how much grip there is on the floor, we can use that to accurately predict the risk of somebody slipping, based on some scientific evidence. So there's been research done since the 1960s on how much grip people need to safely walk over a level surface and what the effects of slopes are. So all I'm saying here is it's not about rubbing our feet on the floor and going, yeah, it's pretty good, or it's pretty bad. We can measure this very accurately. We can relate it quite closely to risk, and therefore we can understand what we have to do to manage that risk. So that's the good news. If we can measure the coefficient of friction, the middle column on that table, we can work out what the risk of slipping is. So what we need is a portable friction test. We need a portable friction test because really we're trying to answer one critical question. And that question is, how slippery is my floor when a person walks on it? And there's two parts to that question, and they're both very important. So the first part is, how slippery is my floor? If you're choosing a new floor to be installed in a factory environment, in a manufacturing area, in an office area, wherever it's going, you need to understand what the slip resistance of that floor is and whether it's suitable for the environment it's going in. However, once the floor has been installed, you also need to know whether it's doing the job that they said it did as it left the factory, whether it's changed over time. And we know that some floors, particularly ceramic tiles, for example, can have a very good level of slip resistance immediately after manufacture, and very quickly within a few weeks and certainly within a few months of being installed and being walked on, they can lose a lot of that slip resistance, where changes the characteristics of that floor. So we need a portable friction test because the first part is, how slippery is that floor? How slippery is my floor? The good news is there are hundreds and hundreds of different portable friction tests out there in the world. The bad news is that most of them don't work. This gives us a significant problem. So I'm not expecting anyone to remember again what the friction tests are that do and don't work. What I'm saying is that beware of test data. There are many tests out there that don't actually simulate what happens when a person walks on the floor. And that's the second part of that important question. How slippy is my floor when a person walks on it? You're not interested in how slippy the floor is when a car turns at 10 miles an hour or a forklift truck brakes from 30 miles an hour, if you can get a forklift up to 30. Those types of friction aren't important. You want to know what happens when a person is walking normally on that floor. What at that point is the risk to them? The point where most people slip when they're walking is as their heel hits the floor surface. If you've got any contamination on the floor, you get an effect very similar to aquaplaning in the car. So if you've got a wet floor, the impact force will create a very thin film of water. If your floor is rough enough, it will break through that film of water, it will make some contact with your footwear, and you'll get some grip. So there's loads of floors out there that aren't slippery when they're wet, or even when they're oily and greasy. If you've got good footwear on, it works a little bit like a car tyre. It will squeeze the water out from that contact patch. You'll still get some contact between the footwear and the floor, and you'll still get some grip. So good footwear can also negate the effects of having water on the floor. The problem is that when the floor isn't good enough and the footwear's not good enough, if you tread on the floor and it's got water on, you'll slide on that film of water rather than getting any grip. Some of the tests out there, some of the examples that are shown in this slide, don't simulate that action at all. So they don't generate that same impact force, they don't simulate what happens when a person walks, and some of them will tell you a wet floor is actually safer than a dry floor, which would make my job a lot easier, but it's generally not true. So there are some bad tests and there are some good tests. And again, the purpose of this presentation is not for you to go away knowing what you should be looking for in all things, but to understand that just because somebody has a data sheet that says that their floor is suitable and fit for purpose doesn't necessarily mean that actually it's going to work in your workplace. In terms of good tests, in the UK, particularly over in Spain, over in Australia, a number of different places, the pendulum test is seen as the gold standard test. And it's what we use here in the UK. The reason is that it's designed from the ground up to simulate what happens when a person walks. There's a number of misconceptions, one of which is that this test was developed for testing cars skidding on road surfaces and then adapted for pedestrians. Actually, it's the other way around. It was developed in the 1940s for pedestrian slip testing and has since been adapted by the road industry for testing cars skidding. But what it does is it generates that same impact, also the same thickness of film that an average weight pedestrian would. So from a technical point of view, it works. And where this test operated correctly predicts a risk of slipping, we tend to see a history of slipping. And where it doesn't, we don't. So there's a lot of confidence in this test. It's been used in the UK since the 60s for testing pedestrian slip resistance. The way you operate this test gives you different results. So it's very important that the operator is well trained, they're experienced, and they're operating the test in line with the best practice. There's a British standard for the operation of this, as well as obviously different national standards in the relevant countries. When I operate this test, I operate to the United Kingdom Slip Resistance Group guidelines, and the United Kingdom Slip Resistance Group are a very dedicated bunch of individuals who come up with the method of operation of this test that gives the most realistic indication of the risk of pedestrian slipping. So that's all to say that when you take this large piece of test equipment, and it's not particularly subtle, and you swing the foot over the floor, it will tell you how much grip there is. So there are some good tests, there are some bad tests. I'm now going to show you the pendulum test in action, not again so that you have to remember how it works or so that you can see some boring testing being done, but to show an interesting effect on a challenging floor surface. So we're going to look now at a very smooth metal floor surface. We're going to swing the pendulum over it in the dry and in the wet. We're looking for anything above 36. Above 36 on the pendulum, when it's operated in this way, the risk is very low of pedestrian slipping. So in the clean dry condition, although this floor is so shiny that you can see a reflection on it, we're getting about 60 on the pendulum, not slippery at all. So the floor is not inherently slippery by being smooth and shiny. Smooth, shiny floors are not inappropriate floors. The problem is that when you put a small amount of moisture on, like we are here, there's a huge difference in performance. So we've gone from 60 down to about 17. That's a risk of less than 1 in a million to a risk of more than 50%, just by adding a very small misting of moisture. Now, some of this is just showing off the slow-mo video capabilities, but there is a point to it. If you look carefully in the image at the bottom here, you should just be able to see the film of water that the heel has slid on. So that lubricating film on a smooth floor makes a big difference. And the pendulum test is very sensitive to that. So when it comes to floor testing, there are good tests, there are bad tests. There's many different ways of testing floor surfaces. And when people are selling a floor surface, they tend to use the one that flatters the product they've got. So in my experience, it's not uncommon to have a floor installed in an area that's high risk, perhaps a manufacturing area or an outdoor area, that was sold as a slip resistant floor, was bought with the confidence that that's what it was, and actually once it's been installed it really isn't doing the job that it should be doing. So it's something to be aware of. We come on to the next part of that hierarchy, the control of contamination and the role of cleaning. Cleaning is very important in terms of managing slips and trips for a couple of reasons. The first of which is that cleaning should remove contamination from the floor surface. So whatever our reason for doing that cleaning, whether we are cleaning for aesthetic reasons to make the floor look better, whether we're cleaning for hygienic reasons, perhaps in a healthcare setting or a food manufacturing setting, we're cleaning to take dirt off the floor. So if the cleaning's being done properly, and it's appropriate to the floor surface and it's using the right technique and the right equipment and the right chemicals, you're reducing the slip risk by keeping that floor clean and critically keeping it dry. Cleaning itself, though, can introduce other slip and trip hazards. So most cleaning is still a wet process, which means that by doing the cleaning, we can be increasing the risk of somebody having a slip or trip during the time that that cleaning is happening. And in fact, for many floors, they only get a risk of slipping once or twice a day during the cleaning process. You might find that for most office floors, for example, if you have a smooth, shiny floor in the office, it will be very slippery when it's wet. That doesn't mean it's an inappropriate floor because it's in an area that doesn't routinely get wet, but once or twice a day it will be wet cleaned and suddenly the risk is very, very different. So the way the cleaning is done needs to be managed in that area in order to keep the risk of somebody having a slip low. In terms of areas where we have greasy contamination, so for example, kitchen environments, food manufacturing environments, motor workshops, if the floor has grease on it, even if it's a good slip resistant floor, it might be compromised by the grease. So it may still offer a suitable level of slip resistance where you wouldn't necessarily expect to see lots and lots of slips. But the grease has compromised the performance of the floor enough that when you wet it, potentially to clean it, it then becomes very, very slippery because the grease perhaps has filled up some of the roughness of the floor surface. So the way that we do cleaning and the way we plan cleaning is really, really important in terms of controlling risk. When we get it wrong, we get very serious incidents. So I'll talk briefly about two accidents that I investigated, or one I was involved in investigating and one I was involved in some of the discussions around afterwards. Two incidents that happened as a result of cleaning, one to a member of cleaning staff and one to a member of staff who was in an area being cleaned. Both of these issues, both of these incidents were completely preventable. Both had very, very nasty consequences. And when we look back, if we were being more proactive about preventing slips, so going from this reactive position to actually thinking about doing something, risk assessing and putting some controls in place beforehand, neither of these would ever have happened. So the first of these was a nasty incident to a lady who worked in the health services in the UK. She worked as a nurse and she had two accidents, both as a result of poor cleaning practices. But the second accident was the more serious. She was working in a carpeted office. About 12:30 in the middle of the day, she went out for lunch. Outside her carpeted office, there was a smooth vinyl corridor, which is very common in healthcare because smooth vinyl is perceived to be easier to clean. That corridor had been wet mopped, so it was completely wet. There'd either been a spillage or there'd been a change of staff or there'd been some other challenge because that wasn't normally the time of day when that area of floor was cleaned. She stepped out from her carpeted office straight onto the corridor and slipped. Unfortunately, she slipped and slid right across the corridor and broke her ankle on the wall on the other side. Very, very nasty spiral fracture. And actually, she ended up losing her foot. Due to complications, ended up losing her leg in sections further and further up until it was up above her knee. So she had a number of operations, over 35 of them. She had several amputations. This is from a very, very simple slip in an office environment. We're not talking about any other complicating factors, no machinery involved, nothing else. Very, very unfortunate incident. For me, there was no need for that to have happened. First of all, there shouldn't really have been cleaning going on during that time of day. It was the time when most people left the office to go and get lunch. So it's the time when that corridor was busiest. Now, it may have been as the result of a spill, in which case there needed to be some thought given as to how much of the area was cleaned. And if the area immediately outside her office had to be cleaned, could they either leave a dry portion of the corridor so that there was a safe area for people to walk on and use some physical barriers to exclude people from the slippery wet area, or could they at least have just gone into the office and warned people that the area outside was wet and slippery? Placing a wet floor sign on that corridor would not have been enough for me because by the time that she had opened the door and stepped onto the corridor, she'd slipped before she'd have had any chance to see a sign, understand what the relevance was, and know that it meant the floor that she was about to step on was slippery. So the use of signs and barriers is quite a challenging one. We make an assumption in many cases that by having a sign out, people will see the sign and modify their behaviour. That can work in the right circumstances, but signs are frequently overused, especially wet floor signs and cleaning signs. And if the floor appears dry, if it's not obviously soaking wet, the perception tends to be from people that the sign has been out for a very long time and it gets ignored. So there were a couple of things that could have been done to prevent that very, very serious and unpleasant incident. The second incident I investigated personally, and that was a cleaner who was cleaning in a retail business. The retailer had done a risk assessment and said, our floors are slippery when they're wet. We don't want members of our staff accessing those floors while they're wet, and we don't want our customers accessing those floors while they're wet. So they thought about how to manage the risk, and they'd come up with a very proactive and very simple solution. Don't allow people on the floors at the time that they're risky, because once they were dry, they weren't risky. The problem is that nobody in this process had thought about how to protect the cleaner themselves, the person who has to be on that floor during the cleaning process. So the cleaner was contracted to come in at 6 o'clock in the morning, 2 hours before the first member of staff arrived. They would let themselves in, they would wet clean the floor, they'd leave the premises, and by the time the first member of staff came in, the floor would be dry. It's a very good system, but nobody had thought about the cleaner. She slipped on the floor whilst wet mopping it, had a very unfortunate break in her leg, and she also lost the leg. So although it's an extreme case, both of these, the last time I looked in the UK, we have on average about 9 amputations a year from people who just slip on the level. So rather than falling from vehicles or falling from height, very, very simple incidents, we still have significant injuries. Both of these were preventable by thinking a little bit about what they could do. In the case of the second incident, what happened was the cleaning company issued slip-resistant overshoes to all of their staff to wear during the high-risk part of the process, and it made an enormous difference. As far as I know, they've not had a similar incident since. But until the incident happened, and this lady had a very, very unpleasant injury, nobody stopped to think whether she was adequately protected doing that process. So cleaning is quite a challenging one, but some of the changes to be made around it can be very, very simple. So looking here at using the right method of cleaning and the difference it can make, I'm going to show another very technical slide because I'm claiming to be a scientist, and really that means I've got to show the graph or two. The reason that I'm showing this is this shows what happens if you use the right technique to clean a floor. And technique is at least as important as the chemicals you have and the equipment you have. So I'm going to explain this graph very quickly. This was a colleague of mine from Canada who did some cleaning in large commercial kitchens, so big pub kitchens, big restaurant kitchens. He went in, he measured how much grease was on the floor, and then he asked the restaurant staff to clean the floor as they normally would. He then measured how much grease was left, and that's the red bar on here. So on some of the floors, for example, if you look at the second flash bar right in the middle, about 75% of the grease that he'd measured in the first place was still on the floor after it had been cleaned by local staff. He then cleaned the floor again in a different area using an improved method, and that's the blue bar. And in most cases, we'll ignore dash for the moment, but in most cases, he made a significant reduction in the amount of grease left on the floor. So by using a better technique, he made a big difference to the amount of grease on the floor. His better technique was to get the chemical bottle, use their buckets, their mops, their equipment. He took the chemical bottle, he read the label, and he followed the instructions. And what had happened in most of those cases was that the restaurant staff had been cleaning in that restaurant for so long, they'd fallen into bad practice. They weren't actually following the instructions on the chemical bottle in terms of dilution, in terms of removing the chemical, rinsing the chemical. And so using exactly the same chemical, exactly the same buckets, mops, and equipment, and taking the same amount of time, he was able to clean the floor far more effectively just by thinking about the process. So cleaning is one of those things that can usually be significantly improved without actually investing an awful lot of time and effort in anything new or expensive, just thinking about where the gaps in your current process are. The one there that didn't seem to work was dash, which was significantly worse after he'd cleaned the floor. Looking at that, I suspect that's because the red bar on dash is very low. I suspect that the staff in that kitchen were cleaning it very well anyway, and I suspect the instructions on the dash bottle that he followed weren't particularly good. But as you can see from this, the way that he did the cleaning had far more impact than the type of chemical that he used. And then as a final example for cleaning, this is a train station in the UK, and they have a smooth, shiny floor that gets slippery when it's wet. It gets wet quite a lot. This is up in the north near where I live, and it rains, well, they say it rains twice a week there, once for 3 days, once for 4. So we tend to get quite a lot of rain. The other problem is that there are flower stalls, drink stalls, fast food restaurants, and there are spillages. So what they decided to do was to have a roving cleaner who's trained to be very reactive, get to the spills as quick as he can, and clean them up. And he's very, very good at his job. So being the dedicated people that we are, somebody from my team, when the call went out because there was a spill at the flower stand, decided to time this guy and see how long he took to get there, because we have nothing better to do when we're sat waiting for a train. So they got the stopwatch out, they timed him. It took him 38 seconds to get from wherever he was on the concourse to that spill. So he's been well trained, and he understands that part of his job is to get to the spill as quickly as he can. When he got to the spill, he dipped his mop in his bucket and dragged it 10 meters across the forecourt to get to the wet spill. So suddenly he's made this enormous extra area of wet floor and massively increased the risk. So he's understood the first part very, very well. The second part he's not really understood. And I suspect it's because he's been told to get there as quick as he can and clean, but he hasn't been explained that actually you're getting there to take water off the floor to reduce the risk of slips more than you are managing the aesthetics of the building. So he's been told what to do, but not why to do it. Now, it might be that he has initially in his training been told why, and he's fallen into bad habits. It might be that he's having a bad day and he couldn't be bothered to do what he was told to do. It might be that he hasn't understood what he's been asked to do. But the one thing that shows to me is that after he'd been trained, it's been a long time since somebody supervised him doing that task, because actually what he's doing is the exact opposite of what he's been paid to do. He's increasing the risk. So just by supervising our current cleaning practices, we can sometimes see where there are gaps between what we expect is being done and what's actually being done. And those gaps aren't necessarily the fault of the cleaner. The member of staff doing the cleaning might be taking shortcuts or doing things differently, either because it's not been explained to them which bits of that job are important, or because they're physically limited and can't do what you've asked them to do in the procedure, either due to time or equipment or space available, and they're doing the best they can. And understanding that can help us manage risk. So as I mentioned, right at the bottom of the hierarchy, we've got footwear. And I'm going to talk about footwear for just a couple of seconds. It can be a very, very effective control. Some of the good slip-resistant footwear will pretty much eliminate slips in most environments, but selecting it can be very, very difficult. The most common standard for slip resistance of footwear is an ISO standard. It's used in America, it's used across Europe, and I'm not going to go into the standards and bore you to death with that, but that standard doesn't work very well. It doesn't simulate what happens when a person walks, so we have a similar problem to some of those earlier flooring tests, and it doesn't challenge the footwear. Every piece of occupational footwear on the market has to have passed one part of this test. So if you buy a safety boot, it has to have passed one part of this test. But by achieving a pass, it doesn't guarantee that it's actually going to help you control risk. So if you're using footwear as one of your main controls for preventing people slipping, you need to think a little bit about additional information. And to get there and to understand what a better piece of footwear looks like, there's a number of places that you can go. The HSE in the UK, so the UK regulator, have their own scheme called the GRIP scheme, which has a 1 to 5 star rating. And this isn't an additional standard or requirement, but if you're using footwear as one of your main controls for risk, this helps you get information above and beyond the minimum that you get from the standard to really understand which piece of footwear you need for your environment. And it's not about everybody having a 5-star shoe and having the most grip available. It's about having a shoe that's appropriate for the contamination you've got, the environments you've got, and the budgets and all the other requirements that you have. So that's worth having a look at. I mentioned overshoes briefly earlier when it came to cleaning. Now, traditionally, overshoes are more of the shower cap plastic bag that you'll see on the left, which make no difference whatsoever, and from a slips point of view, actually prevent the footwear touching the floor and therefore increase the risk of somebody slipping. But there are some very good slip-resistant slip-on overshoes, which is what was used with the cleaner following the nasty injury that I talked about earlier. That's what was issued to the cleaning staff. So there are some good slip-resistant overshoes, but again, they need to have been tested to a relevant test so that you can understand whether they will help you manage risk. And then there are many examples of where footwear has made a big difference. So one of the ones I was personally involved in was an energy company who had lots and lots of staff working outdoors. So they had lots of issues in the winter months with snow and ice. And footwear that does well in smooth, wet floors in internal industrial environments or office environments can also do very well in snow and ice until you get to a certain point. So if you're dealing with very cold winters, I've also done some work on sort of extreme temperatures below -20. But for the UK, we worked with them to help identify a better piece of footwear. They went from 2 bad back-to-back winters, one where they had 74 lost time incidents, and for a lot of the winter, they stood their workforce down for fear of injuring someone. The following year, they worked every day, and they only had 1 lost time incident. So the footwear to them made a huge difference, and the cost benefit of that footwear was enormous. They'd paid, I believe, £1 or 2 more per pair, but they'd saved thousands and thousands of pounds. Trips I'm going to talk about very briefly, and then we'll finish off talking about stair falls. And trips, we've all had one. We all know what they are. You catch your foot on something you weren't expecting. If you're walking forwards, you tend to fall forwards. If you're walking backwards, you're more likely to trip because you're less likely to see the hazard, and you'll fall over backwards. In terms of trip hazards, we all know, we can list them: doorstops, trailing cables, all those types of things. The only thing I'll say from a scientific point of view on trip hazards is it doesn't take a lot to trip people up. So anything 10 mil and above can be considered a trip hazard, and the larger it is, the more likely it is to trip you up. So in the UK, for example, our highways engineers, when looking at pavements, will look at an action value of about 25 millimetres, about an inch. Anything that high and above, they will look at whether it's worth making some kind of remedial action and fixing that problem. And again, they do that on a risk assessment basis. So if it's a main high street that's very busy, they might take action at a lower value. If it's in an area with very low pedestrian traffic, they might leave it at a higher action value. But that sort of 25 millimetres an inch is where they start to think about something being a significant trip hazard. So for the last 5 or so minutes, I'm going to talk about falls on stairs. And as I mentioned before, falls on stairs tend to lead to the most serious injuries in my line of work, looking at slips, trips and falls. And I believe I've investigated a fatal stair accident, at least one, pretty much every year that I was at the Health and Safety Executive. They happen in very simple and innocuous environments. So they happen in retail spaces, in leisure environments, they happen in public spaces, they happen in office buildings. We think of large industrial stairs potentially being an issue, and I've got an example of a few of those, but actually all environments with stairs can potentially have a significant risk of people falling. And it's largely down to stair design. There are a few things that give rise to a risk of falls. We tend to think of falls on stairs as being human error, people not paying attention. And while every stair fall will have human error in it at some point, the chance of a human making an error on stairs is enormously influenced by the design of the stairs. And we don't think about what we're doing on stairs. And I believe the last webinar, there was a little bit of conversation about the amount of pieces of information people can hold in their head at any one time. That's very, very true of stair use. It isn't a conscious process. So having a sign at the top of a flight of stairs that says, please don't fall down and die, doesn't really have an impact on whether somebody will fall down and die, because we don't read it and genuinely take more care. It's a completely subconscious process. So what we're actually trying to do is give people the right physical and visual cues in that staircase that they make those subconscious judgments correctly. So some design features that give rise to risk are the dimensions. Obviously, the steeper a staircase, the larger the height between each tread, so the rise, or the smaller the going, the smaller the area you've got to place your foot on, the more the chance of a large part of your foot overhanging the front of the tread. And that's when people tend to have slips. Even if the surface offers quite a good level of grip, traditionally, if a lot of your body weight is forward of the front of the tread, there's still a significant chance of your foot slipping off that tread. In this example here, this was from an incident investigation my team did, where unfortunately somebody died. And it's very common in a number of different public premises. The top step is half the height of all the others. And that will really throw people out, because you take your first step, particularly in stair descent, so going down where the most serious injuries happen, you'll take your first step down and your brain tells you, well, all the other stairs will be this high, because the easiest way for your brain to walk downstairs is to assume that those dimensions will be consistent. Next time you take a step down, you fall a good half that step distance, because you put your foot down where you expect it to be and put down your full weight and have what's called an air step. So the chances are you're going to make a mistake right at the top of the flight. And I investigated a restaurant in the UK only last week that had this defect in, and we're in the middle of what you can do to fix that. And you can eliminate these design defects actually quite simply in most staircases without ripping the staircase out and starting again. So the dimensions will have a big impact on risk. The visibility of the edge of the treads has a huge impact on risk. So in this case, we have an office stair. It's got very poor delineation of the edges. So it's very difficult to see where one step starts and the next one ends, which makes placing your feet accurately difficult and increases the chance of mistakes. It can be seen a bit easier in this example. So in this industrial stair, it's really difficult to work out where the treads end and where to place your feet. We can do it sitting here looking at some slides, and we can work out where the treads go. But actually, when you're using that staircase, it's very, very challenging. Now, in the same work environment as this, I came across a second set of stairs. I took all these photos. The second set had a highlight on the edge. So on the very edge of the tread, or the nosing, there was a highlight. Wasn't an example of excellence, wasn't a particularly good highlight. It was just a metal bar welded on the edge. But look how much easier it is for your brain to pick out the treads here when compared to here. And that's the problem, is you can't make yourself do it better. It's all subconscious. So what you need to do is make sure that people can see that. And that applies equally to industrial stairs, to internal stairs, having a highlight on the edge of that tread significantly reduces the risk of misplacing the feet and having an accident. And then obviously one of the other big issues on a staircase is the handrail. In this case, this is in a hospital in the UK, the handrails are painted the same colour as the wall. That can give people a big issue because when they're approaching the staircase, they don't necessarily see where the handrail is and fix it in their spatial map. So while we can sit here and see where the handrail is, if you were to fall on that stair, research has shown us that what most people will do is start to look for where the rail is. And by the time they've seen it, they've already fallen. Actually, if the rail is painted a different colour, people will see it as they approach the stair. And even if they're not holding it, and perhaps later on we'll talk about hold the handrail if people have got questions about that. But even if they're not holding it, they've got about an 80% chance of using that handrail to safely stop a fall. So even a lick of paint on a handrail can make a very big difference to risk. And I'll finish off with another example on handrails. And unfortunately, this was another fatal incident that I investigated. Again, a very simple location. It was a retail space, doesn't look particularly dangerous. And a lady was shopping and fell from these stairs. Now, the stairs at the top, both flights, the handrails are 1.8 metres apart, which is the absolute minimum allowed between handrails in the UK. And there's a reason for that. It's so that when you're on the stair, if you lose your balance, you can reach one rail or the other to stop that fall. Unfortunately for her, she fell from the third or fourth step up, and she was in the middle. And what we know is from her height and the fact that these handrails flare out at the bottom, she wasn't able physically to reach a rail, which meant that once she'd started to fall, she had no choice but to fall all the way. After she fell, they straightened the handrails, they flared them at the edges, and they used the area to display sale items. A much better solution, but as I said right at the start, the reason they did this was in response to somebody unfortunately falling and dying on the stairs, not something they'd identified by assessing the risk on that stair in the first place, which would have been the better way to do it. So I know that's been a real whistle-stop tour. I've thrown loads of information at you. There's been some technical stuff and some graphs, but the really key important message is falls can be prevented. And working with a whole range of organisations over the last 15 years, we've seen some significant fall reductions with very, very simple interventions. The challenge you've got is that the solutions are usually very simple, but it can be misleading if you rely just on test data. And in terms of preventing slips, we think about that slips hierarchy: flooring, contamination, cleaning, footwear. Trips, often a housekeeping or a maintenance issue, although we do get some other sort of permanent designs around buns and so on. And naturally, if anyone's got any more questions from a really technical point of view, then I can assist with those offline. But thank you very much for your attention, and I'm now keen to take any questions you might have.
Excellent. So thank you very much, Rob. That was really, really informative. There's a lot of information there, you're right. So we're going to go through the Q&A aspect now. What you should notice is that you've now got an additional word at the top on the left-hand side, which is a raise hand option. So if you have any questions you would like to ask verbally, then you can use this. And what we'll do is we'll go through each person. I'll give you audio rights and let you know when you can ask your question. So make sure that you do have a microphone and speakers so that you can hear and be heard. Failing that, of course, we also have the written questions that you can also send in as well. So as a reminder, we are recording this session. But what I will do is for the actual recorded version, we won't have any sort of cameras or anything like that on display. So we'll kick off with a first one, a question in writing, and then we'll go open up to the floor. So someone has asked a question here. Would you have any tips preventing slips, trip and falls regarding the behavioural aspects more than technical?
That's a very, very good question. It's a challenge to combine both. And I think the thing I've had the most success with actually is training and awareness. My experience is most people in an organisation, actually, they understand their own organisation, their own working space very, very well. They don't need to know all the technical stuff that I've been showing you today. What they need to know is what's relevant to them. And really just an understanding that slips and trips can be serious. They can injure people, not just themselves, but their colleagues. the best behavioural interventions I've seen have been where somebody's had an accident or an injury in a workplace, and the workplace has used that as a communication. So for example, I saw somebody had fallen in a toilet and they'd broken several fingers on their hand. When I went in that toilet in the business, they had a photograph on the wall of the person's hand with all bandaged up and so on, from the point of view that you enter that room, and it just had a simple message that said, your colleague, didn't name the person, but everyone knew who it was, your colleague slipped in this bathroom because you know, a spillage hadn't been cleaned up or because there had been something on the floor, and they were off work for X amount of time. And in that bathroom, when I went in, was absolutely immaculate because it made people sort of take that personally. So I think that level of communication works very well.
Okay, great. Just have another one. Some companies have got quite a strict sort of you must hold the handrail rule. In your opinion, is this helpful?
Very good question again. This is one that the experts sort of debate backwards and forwards. The scientific evidence is that if the handrail is well designed, it's at the right height, it's easy to grasp and so on, you don't need to be holding the handrail to arrest a fall. People have roughly an 80% success rate if they fall at grabbing a handrail and stopping the fall without needing to hold the rail. However, hold the handrail has one significant benefit to me, and that is it prevents the most dangerous activity you can do on stairs, which is carrying objects in both hands. If you're carrying an item in both hands, it limits what you can see ahead of you, it puts your balance off, and your natural reaction on losing your balance isn't to let go of the object and save yourself. Actually, it's to grab onto the object for dear life, and so it tends to lead to more falls. So a hold the handrail policy is a good thing because it prevents that dangerous activity. The one thing I would say is that I have been in several organizations with very strong hold the handrail policies who have very poorly designed handrails, and holding their handrails would make very little difference to the risk of having an injury. So both things are important.
Okay, great. That also actually answered a follow-up question on that one, which was whether you recommended them. So we're going to open the floor to Richard. So Richard, I've just allowed you to talk, and I've just unmuted you. So if you want to go ahead and ask your question.
Yeah, thanks. Hello, Rob, and thanks for the presentation. Actually, just an hour ago, I was on another call where someone shared a lesson learned from one of our sites in Canada, where a person fell or slipped, sorry, on a car park while going to work because of snow, and they have quite heavy conditions there. So we had regular talks about winter safety plans, things like that. It's a bit difficult as well to work on the footwear of the people because they are not yet at work. So they have their personal shoes there. So would you have any specific tip or advice regarding this type of risk?
Absolutely. It's a very challenging one, particularly Canadian winters, for example. I've done some work with Toronto University, who've done some research on slip resistance of footwear in that condition. But as you say, this is before they're in potentially controlled footwear. I think the biggest challenge for me with icy conditions is to plan ahead. So wherever possible, be prepared for them, do something in advance. And I suppose simple advice in a short period of time would be look at the most commonly used car parks and pedestrian traffic routes. There was for a little while in the UK a bit of almost a backlash where people would say, well, we're not going to clear the car parks or grit the car parks because if we do a bad job of it, we will be liable and we will, you know, we'll be in trouble for it. And actually that really wasn't the opinion of the regulator. It was, you need to do what you can do. It's very difficult to completely eliminate risk in snowy and icy conditions, but if you can focus on keeping open the critical car parks, making sure that the footpaths and the access and egress to those are well cleared and gritted, and sort of focusing on those key areas, that's where I'd start.
Yeah, thanks, Rob.
Okay, great. We've got another one in writing here. If anyone does have any questions they'd like to ask verbally, obviously please raise your hand. But this next one then is, do you have accident statistics in the UK on fatal falls from stairs?
Good question. There are statistics. The stair statistics in the UK are a little bit difficult to access because in 2013 in the UK, stairs were removed from our reporting system as a causal agent, largely because they are consistently underreported as a cause of incidents. I know that in 2010, 2 fatal stair accidents were reported to the UK government in the workplace, and I personally investigated 6. So at least 4 had gone unreported. Because of that, they were removed from the statistics. We do know, however, that from statistics in one of the UK standards, as of 2010, there are about 500 domestic deaths every year, and somewhere around 100,000 injuries in public spaces. So it's a significant issue.
Okay, we don't have any more outstanding questions, but we do have a bit more time. One of the things that someone has just asked, whether you could maybe talk a little bit more about handrails. I know that a lot of the questions kind of have related back to those, but have you got, you know, in the next sort of few minutes, have you just got any kind of pointers or anything that you want to talk about with regards to handrails that might be useful for people listening in?
Yeah, absolutely. I think the critical thing for handrails are, we've talked about colour contrast. They need to contrast with their environment where possible so people can see them. And the research that was done actually wasn't done far from Switzerland, if I remember rightly. We weren't allowed to do it in the UK because it involved pushing people down the stairs. Very, very interesting piece of research. As people walked towards the stairs, they were in a fall arrest harness, and the stairs were shaken to make them fall. The people who walked towards the wall where the handrail was the same colour, none of them noticed the handrail because they were tracking where they were looking with sort of the Google glasses. Nobody looked at that handrail, and when they shook the stair, everybody started looking for it and everybody fell. When they'd painted it a different colour to the wall, everybody noticed the rail and everybody reached for it just with peripheral vision. About 80% were successful. In terms of that handrail being successful at arresting a fall, it also needs to be at the right height, so a predictable height. That will vary slightly based on building codes in different countries, but generally speaking, all building codes put handrails roughly between about 800 millimeters and a meter, 1,000 millimeters, because anthropometrically, ergonomically, that's where we naturally reach to grasp. And if all the handrails are roughly the same height, we train ourselves to know where we should be grabbing for a rail. They also need to have enough clearance from any walls or any mounting points so that you can get your hand clearly around it without skinning your knuckles. And they need to have a very small profile. This is quite critical. One of the biggest problems I see with handrail design is that handrails are too large for you to get what's called a power grip. So a power grip is where your thumb and finger can meet in the middle, because you're able to actually exert force from both sides of your hand. That increases the strength of the grip you can generate, and it'll take about 80% of your body weight. It gives you a very good chance of arresting a fall and preventing a serious injury. If you've got a much wider rail, even if it's very comfortable and contoured, if you can only get a pinch grip like this on the rail, when you fall, that can't generate enough strength to stop your hand being pulled off the rail. So actually the shape of the rail is also very, very important. A circular rail with a diameter of 32 to 50 millimeters is ideal for most people.
Great. Okay. Had a couple more come in whilst you were just talking about handrails. So someone has asked, can you recommend any good slip trip inspection forms available from the HSE?
Well, the HSE website has a slips trips page, and certainly that used to have on it. It's been reviewed recently as part of HSE's review of various things. My involvement in that was to keep everything we've got, because it's all very good, it's very useful for people, and I wrote some of it, so I'm quite keen for it to stay there. They've got a lot of guidance on cleaning and a number of other things. They used to have a hazard spotting checklist on there. So if you go to hse.gov.uk/slips, those are the slips and trips pages, and I believe it's under the resources section. There used to be a hazard spotting checklist.
Okay, great. So a scenario one here. So referring back to the icy conditions aspect, does it make it your problem if you were to grit a public path? So this person, they work in a school, and often they need to grit the entrance outside the perimeter. So if they're doing that, does it make it their problem?
That's an interesting question, and one that I get asked most winters. It's a very difficult question for me to answer. I can only really answer it from a UK perspective, because I'm not familiar with the regulation in other countries as well. In terms of UK regulation, your legal duty is to do everything reasonably practicable to ensure the safety of people who do work for you and who are impacted by your work. So the argument of the UK regulator, HSE, has always been that any paths, particularly paths that you control, should, where possible, be gritted or be fenced off so that they're not used. You're better off gritting something and not quite getting all the ice than you are doing nothing, because by doing nothing, you've absolutely not done everything reasonably practicable. So you've definitely failed in that sense. If the question is about gritting areas outside your jurisdiction, but on sort of land adjacent, that's much more difficult. From the point of view of risk control and I suppose moral obligation, I would argue that if that's something that helps control the risk outside that area and you're able to grit it, I would argue that by doing so, even if the gritting doesn't get rid of all the ice, because it's very difficult to do that, you've taken the extra step and you've gone beyond, in my opinion, to actually help protect people. The challenge is, I don't know legally or locally what the legal stance would be on that.
Right, okay, great. We are at the end of the time. There is just one final question. I am going to quickly ask it because I think it's a good one. And that is, in the food preparation industry, hygienic overshoes are required. As you said, they do decrease grip dramatically. So what would you suggest to tackle that issue?
That's a big challenge. In the UK, we don't have quite so much of an issue with the overshoes. It tends to be that there's designated footwear for designated areas. For example, you would, before going into a certain part of food preparation, you would change into a different pair of designated footwear, and that allows you to then have the sole and have the grip. If you're in an area that has to use the overshoes, I would recommend looking at how cost effective it would be to shift to a slip resistant overshoe, which are certainly machine washable, may indeed be autoclavable, and have a long lifespan, particularly if people aren't working in those environments for particularly long periods of time. It might be that having one pair of overshoes per person is not much more expensive than buying a huge number of the plastic bags, certainly more environmentally friendly, but it will offer much better grip. The other option would be to have very good slip resistant flooring in that area. My experience is that will shred the bottom of the overshoes, which actually will give you excellent grip then, but is probably doing away with what you need your overshoes to be doing in terms of hygiene. So I would look at some of the potential sources of slip resistant rubber overshoes as a more permanent replacement.
Excellent. Okay, well that is the end of the session. We have got through all the questions, which was brilliant. Rob, that was a fantastic presentation. I thoroughly enjoyed listening to that myself as well. Alison, I think you wanted to say a final couple of words just before we ended.
Only just to say thank you to Rob. That was a fantastic presentation. I know he knows so much about this subject. I've listened to one of his fuller presentations, and there's so much more that he can say. But it was great for him to share that he has done and to manage to fit it into such a short time. So thank you very much, Rob.
You're welcome.
Definitely. Once again, thank you very much, Rob. Thank you, Alison, for being involved, and thank you all to you guys as well for joining in the session and for your questions. We really hope that you found it useful, and we'll be in touch in due course. So take care.